Okay, we're going to take a look at problem 1, chapter 6, very simple centroid problem. We have a kind of a triangular shape and a square shape that we're going to be utilizing to get the centroid. What they give you is that the origin is going to be down here, and we're going to have this as our x-axis, and this is our y-axis. So this is our y. So we have x, y, and origin. So we also have dimensions that are given. So we know that this is 1 millimeter, and this is 2 millimeters across. And we do that. This is 1 millimeter here, and this is 3. So we have to break this down into simple shapes because we don't have anything on table 6.1 that allows us to just go in and generate this. So what we want to do is break it down into something we can handle. And if you look at this, we've got a square and a triangle. So what I'm going to do is break this out. My triangle is here. So I have my triangle here, my square here. So we're going to give this a shape. We're going to call this shape 1 and this shape 2. Okay. And that's just for identification purposes. So what we have now is a 3 millimeter by 3 millimeter triangle and a 1 millimeter by 1 millimeter square. So utilizing the composite shape little diagram or chart, we're going to have our shape. Then we're going to calculate the area. Then we're going to calculate the x distance, which is the distance from the origin in x to the centroid or y-axis of that shape. Then we're going to multiply the a times x. Then we're going to calculate y, which is the y bar distance to the xx centroidal axis of the shape. We're going to multiply y times a. So we're going to end up with ya. So we have shape 1, shape 2. So we'll start out with 1. We calculate the area. 1 times 1 gives me an area of 1 square millimeter. The x distance is the distance from the origin. So the origin is this line. Essentially, half of the distance over gives me 0.5. 0.5 times 1 is also 0.5. So y, we have to generate it from the origin up. So we're going to go 3 millimeters plus half of this distance. So that would be 3.5. 3.5 times area gives me also 3.5. So the units here are millimeters squared, millimeters, millimeters cubed, millimeters, and then millimeters cubed. And we'll see at the end that we'll wind up with millimeters as our distance unit. So the next thing we got to do is look at the triangle. Triangles are a little tricky sometimes. First, we calculate the area. Area is 3 times 3, so it's 1/2 the base times the height. So 3 times 3 times 1/2 gives us 4.5 square millimeters. So then the x distance, if we're coming this way over, we would be 1/3 of the distance from the large end of the triangle or 2/3 of the distance from the small end. So basically, we're going to take 1/3 of 3, and that gives us 1 unit or 1 millimeter. 1 millimeter times the area gives me 4.5 millimeters cubed. So then we have the distance this way. So again, it's 2/3 of the distance this way, or 1/3 down. Since we're coming up, we're going to take 2/3 of 3. 2 times 3 divided by 3 gives us 2. So that distance is 2 millimeters up. 2 millimeters times the area gives me 9 to the 3rd. So we're going to then sum this column, which gives me 5.5. Sum this column, which gives us 5. And sum this column, which gives us 12.5. So by equation, x bar for this shape is the sum of the a-axis divided by the sum of area. So that's 5 divided by 5.5, and we get 0.909. And that's a distance unit, so that should be in millimeters. And notice this is millimeters to the third, millimeters to the second. So to the third divided by the second does give us millimeters, and that makes sense. So centroid x's and y's are always distance units. So y bar distance is the sum of a y divided by area. And that's going to give us 12.5. That's our AY sum. Divided by, again, an area of 5.5. That's our sum. And when we do that, that gives us 2.273. That would also be millimeters. So if you were asked to draw this, which is kind of a good thing to take a look at sometimes, what that's saying is the x bar distance is almost about right here. So it would be this distance. And the y bar distance will be, there's 3, it's 2 point something, maybe about right here if I'm just visualizing it. And so what we would have is, there's your y bar distance, there's your x bar distance, and this point approximately is where your centroid is.